Hello. So this is a test. We have been designing a SCADA system. So this SCADA system is built to run machine learning natively in the SCADA environment. So for example, you go to our properties, you'll find that this is a HMI device. It's a HMI version 001. We're using a WaveShare 10-inch, um, and it's running on a SBC that contains an NPU. The NPU has a capacity of 1 TOPS. So this model is for a Jaka Zu5 robot. We are trying to find the remaining usable life for each and every joint of the Jaka robot. So this requires us to have a SCADA system that has the capability to run machine learning models. This currently does not exist in the market. So what do we have first? So we have the basic SCADA system with the alarms, the analysis page, and the dashboard. We have built this designer and the runtime, which you will see in short order. And they are independent systems. So now, what do we have currently? So I am rebuilding this project. It's for my master thesis in mechatronics, and I'm building it again because a few things that I want to change, and I'm using this as the reference. This was the initial project, but now we are using this as the reference for the new instance. Um, This is our dashboard. Majorly contains more or less the same things. This is a DC motor with a gearbox, and each and every joint is well represented. We have the labels, we have the numerical views. These are basically SVGs, um, and these are custom indicators. So this is an indicator that can be configured. We have the daytime, we have the navigation buttons that help us to navigate between alarms and analysis. This is my university logo, and now this represents our HMI view. We have a start button, stop button, the jog, and the reset. Now, um, our SCADA system will be communicating using um, we have OPC UA. We can configure multiple communication channels. We have Modbus TCP/IP. We have Modbus RTU and OPC UA. For now, the rest are not configured. They're just placeholders. Um, our project is designed to use OPC UA. We are also not going for OPC because it's outdated. Um, and in our configurations, we can either configure our OPC server as our OPC as a client or a server, or both in unique instances. For now, we maintain this. So these are the basic configurations for OPC UA, and we maintain them. We are using anonymous for now and no username because these are low security instance. We have to expose tags when we come to communication because as you can see, our OPC, if we configure our OPC is configured as a server. You can also configure it as a client, but it's configured as a server. So we come to tag mappings. There are none here, but if this was configured as a client, we would we'll click on OPC, which will allow us to connect to an OPC server, and we will fetch the nodes or the tags from that have been registered in the OPC server. Now, here we have the tags that we have in our database, in our tags. So we have the default tags, we have these, and we have the machine learning tags. So now we will not expose the machine learning tag because we really don't want to feed the data outside as of now. This is housed internally. what we want to expose are these tags. Now, these tags will be fed will be the data, the sensor data that we collect um, from the Jaka robot. So which tags do we want to expose? So we come here and let's format this way and let's click on all. Then we can remove some of the tags. Now we don't want to expose the RUL values. So joint 1, joint 20, joint 6 RUL. We don't need to expose that. Joint 1 label. We also don't need to expose joint 1 label. Let's maintain this. And then once that is selected, we are set. And finally, we have schedules. So here we have configured 2 machine learning models. We are going to see these in short order. So ML, this schedule will be running this joint 1 machine learning model, the RUL model, and joint 2 will be running the model for joint 2. So all the rest, the up to the 6th model, they will be they'll be configured here. But for now, we want to run the first and the second. When we go to the machine learning section, we can see this is our machine learning section that allows us to configure a model. So this is based on the RKNN NPU. We have configured the inputs, so the tags that are available and what the model expects. The outputs, the RUL in hours, and these will be fed into a tag. Some few parameters, but these will not be configured for now. So this is correct. Now, when we are running on CPU, we configure this from RKNN. So we are using the ROC chip. So instead of ROC chip neural network, we go to the Open Neural Network Exchange. So these will run only on CPU, and the model selected will be the model widths are converted to ONNX model. So this is what is usually converted during training. Here is where we do our training. So we can go to model selection, RUL, leave it as it is. Model configuration, we have no hyperparameters. We go to parameters. We can select a few parameters. So this is the training data. Training script is usually contained in where you have it's a Python script. The requirements, so the training script. So I have added the training script and the requirements.txt file. So these are usually shipped with the model itself. So this comes from the RL model, as you can see here, and this is what helps us to train using the Python um, installation in our PC. The requirements file. So these, we also add this so that it can be automatically downloaded by our model. And we have everything else here. We go to the inputs from the data source. Now from the data that we have uploaded, we select the voltage because that is what we expect. We also select the current, the temperature, and the torque. So these values are actually what the headings on the CSV file. So in this instance, we are using the CSV file. So here we can run training arguments, and model output directory can be configured. And these will help us to convert to RKNN. So point to note, you need Ubuntu PC, WSL installation for Ubuntu. You need Python environment installed. you need the RKNN tools configured on your Ubuntu WSL installation. And finally, this is what will be output for the ONNX model and the RKNN. So you can change the names for these and you can have them as you want. So you can test WSL if you go to properties, and you can see our WSL is in this IP address. We can also test the RKNN toolkit that is housed in our WSL. So I should have this. So we can see here the WSL is available. The RKNN toolkit is available. And after training, we can do the conversion. This will convert our model to the right parameters. Now, after training, we can do some validation. Now, we cannot do validation on this PC because unfortunately this PC is running this node doesn't have an NPU. However, we can do this. We don't have a converted model. Okay. So here is where validation, we will select the ONNX model once we have trained it, and we can do the validate, and we can give some dummy values here, and you can actually see the output that you expect. Now, back to our dashboard, this is what we have, and it will be interesting to see how these will run. So you see a few values being presented here. We have to do a few changes, a few updates to our values. So for these, we go to properties and general. We want to attach these to a tag. So tag binding, and that will be current, if I'm not wrong. J1 current. Let me confirm. Yes, that's J1 current. So this is the J1 voltage. J1 voltage. This temperature. So tag binding will be J1 temperature, and this is torque. So tag binding will be J1 torque. We do the same for our joint 2. Tag binding current J2. For this, we have voltage J2. For temperature, we have temperature J2. And for torque, we have torque J2. Okay. So it's always good to save all the files because sometimes it tends to crash a little, but that goes for every new development. So let's close all these because we don't need these. Now, we will need to do a few more things. So this is the start button. We will need to start our model, our robot. And to do that, we have to create an event. So button 1 start event 1. So it's not screen navigation, this tag operation. And we want to set bit. And the tag that we want to set bit is a start button. So start, it's a Boolean value, M0.6, and we save. Now, we can also stop, but for now, we are not going to set stop. We need to start our joints, and we are going to add an event and our join. So it's a tag operation. We set bit, we toggle bit. For this, we are going to toggle the bit, and we toggle the bit for joint 1. Okay. And these, oh, we never saved. So it's always good to save, because if you don't save, it does not pick up the tag. So joint one, okay, and save. Always remember to save. The second one is we add an event, join to tag operation. Right now we just go to toggle bit and we want to toggle joint to. Okay, and we save. So we expect to see some values here, some values here. Now, we already have an ONNX model available. So we should be seeing some values here. So this is configured to RKNN. Now, since we are running the model on our PC, we shall not see any values on the RKNN because it will not be started. However, on the joint 2, which is running on ONNX, we expect to see something. So let's do this. We click on runtime. And we have our runtime environment, as we can see from here. We need to now start our robot. And this is quite simple. It's a Vim script, Python main. So as of now, it has not picked up the OPC because we have not yet configured OPC correctly. So we need to build the project. We have built our project. We need to download to our HMI. So our HMI is running locally on this address, and we deploy. And as you can see, it has transferred correctly. And here is our HMI. And you can also see that our OPC should connect now. Yeah, failing to connect to OPC server. So yes, the reason this is failing to connect to the OPC server is because it's configured to this IP address 192.168.137.10. So that is our actual HMI. You go to properties, target device, that is the address of our HMI. So we need to change our script to be running locally. So let's edit in Notepad. It will be much simpler. And we come to here. So we change this and file, save. And with that, Control C. Let's clear again. Good. Now it has connected to our server. And the interesting bit is, now that we have our server running, if we start our server and we can see some values, and we can see, so our joints are running. Of course, we can make this much better by improving the outlook, but we can see the values of our joints. So we are going to make this project much better. Here in connections, if you click connections, you can see the number of OPC clients connected, how many are transferring and such, but this is not important for now. For now, we are interested in these values, in making sure that this project is correct. So I'll be making some more videos for each and every of these buttons, to show how these it's designed to work, how it's designed to to save the files, communicate, animations and such activities. The next time we're also going to be bringing our actual HMI device, and we will see the same device connected now to our PC functioning as a simulated robot. We will actually see how the HMI looks looks in the actual HMI device. Um, yep.